Now, finally, I'm going to compare the two arrays. So, use the variable home losses and store the result in strong out home. So, count the number of teams that have lost less than 3 matches at home. So, it is very simple. So, we are going to compare the home losses and we are going to see if the value is less than 3. Okay. Very simple. Number of non-zero values of home losses less than 3. So, two teams are very strong at home. So, I'll submit the answer. Correct. And further practice, if you want, how many? Yeah, I'll just run this command. So if three things they have given, see the first things, compare home wins to away wins and see if all the top teams have more home wins than away wins. All means I would use all the top teams. Next one, you see how many of the bottom 10 teams have more home wins. So I have to use n minus 9 to n, not of non-zero. Okay, I'll run this section, you will get the answer. The number of home losses, in the top 10, all teams having home wins 0. There are some teams which have lost, and number of last 10 teams having more home wins, you have 8 teams in that category. Again, I say I am not finding out which team. I am just counting and saying how many teams are going to fit under this criteria. Please understand, we are just counting and saying, we are not exactly locating which team is going to be having that position. Okay. Now we are going to identify the location of the true values. We are going to identify which team is going to do that. Okay, see here. So already we have this home winning and away winning, and home winning only means home winning and no away winning. So I am executing the 3 commands. Now see, create a logical vector home winning only that contains the values of teams that have positive record playing at home but not on the road. So find the result indices of the teams and store the value in IDX. So I'm going to find the index of the team. So index I can definitely see which team. With the number, I can definitely see which team. See here, IDX equal to find of home winning only. So I'm going to see which all teams are winning only at home, not away. I will run the entire program. So the teams 5, 9, 12, and 18 are winning only at home. They are not winning away. So using the index, I can locate the position of the team. From the position, I can see which team. Here, IDX is going to find means it's going to find the position of the required variables for us. Okay. It will find the position of where home winning is true. 1. Wherever home winning is 1, it will find the index of that particular array. Okay. We'll submit here and see whether the answer is correct. Yes. Same way you are going to do for a home losses. So I'm going to use the command here. See what is given. So use the variable home losses to find the index of team that have lost less than 3 matches. So the command will be changing. The find of home losses less than 3. You run, you get the answer 1 and 5. So 1 and 5 are the teams which have lost less than 3. They are very strong at home. That is a strong home index. So very strong at home. They have just lost less than 3 matches at home. Less than 3 means they have won all the matches 0, or they have lost 1 match, or they have lost 2 matches. Okay, so that is the consideration. How to find the corresponding team? Use this notation. You can find the corresponding team. So team, the strong home index, I am giving it here, and see what is the answer we get if we execute this. I will execute the first command. We'll see. You get the answer. First, see, 1 corresponds to Leicester City and 5 corresponds to Man United, Manchester United. So from the index, you're getting the team name using the team array. The team array has the array of names. See here, 1 corresponds to, see here, 1 corresponds to Leicester City. It's coming correctly, and 5 corresponds to Manchester United. It is also coming correctly. So from the array, we are finding the index. From the index, I'm finding the team name. Okay, that is what we have done here.